In this nugget, we get to take a look at a troubleshooting scenario with DHCP that will both increase our awareness of the different conditions that can exist and how to check for them and correct them. Let's begin. For this troubleshooting scenario that you and I get to walk through together, I'd like you to imagine that we've been hired by a company and they want us to help them or assist them in resolving some DHCP related issues. And so they hand us a list, and here it is. They say that scope 10330 has an unequal split between DCNUG and server 2. That's this guy and this guy. So as part of that, we ask them, well, what are you looking for? And they say, well, we want a 50-50 split. But right now, they say, it seems like there's a huge number of leases for the 10.3.3 scope on DCNUG and not very many at all on server 2. So we make a note of that, and then we go under our second item. And that is that clients on the 10.0.0 network, that's up here in our topology, they can't get an IP address or renewal via DHCP. So originally when we set that up, we had DCNUG here, we had a DHCP relay on Ethernet 1 up here on server 2, which was also acting as a router between those two networks for IPv4. Or if server 2 has a local scope for that 10.0.0 network, that would take the relay out of the picture. So we'll take a look at that to see what's going on with the 10.0.0 network. Third, we have clients on the 10.0.1 subnet, which, very similar to the 10.3.3 network, it doesn't show up in our topology here, but we can still look at the scope information and take a look at what's going on with the scope. And then last but not least on our list is server 2-NUG seems slow to respond on all scopes that it's currently supporting. So what we get to do is we'll go to client NUG and we'll do some remote administration for DHCP with DCNUG and server 2. And we'll look at many of the components that we've configured as we've gone through these nuggets together regarding DHCP. And I'd also like to, in this process, show you a couple of additional things we might check in this troubleshooting process. So in our hands-on lab environment, let's go over to client-NUG. So here on client NUG, let's go ahead and launch the server manager using the icon in the taskbar. In server manager on the left-hand side, we'll click on DHCP, and then we'll go ahead and right-click on one of our DHCP servers in the list. And from the drop-down, select DHCP Manager. And to bring the other server in, we can right-click on DHCP and say Manage Authorized Servers, or we can use this icon right here, which gives us the same option to go ahead and click the radio button next to Authorized Servers, selecting Server 2, and clicking on OK. So now we have both of them in the list, and we can expand these as well. So initially, when we bring this up, looks like we have green. Green here, green here, green here, green here. So that's one of the first things that we would look for is whether or not we have some kind of an indicator. Also, if the DHCP service was not running on a server, that server, it would not be showing us the individual scopes and so forth beneath the server if the service is not running. So as far as our DHCP problems, both servers have the DHCP service running. So let's go ahead and expand IPv4 by clicking on it under DC-NUG. And we'll also do the same for IPv4 under server 2. And look at that. When we expanded it, it changed the icon here next to IPv4 to an exclamation mark. And then there's also an exclamation mark here for scope 10.0.0. So that was our second item on the list, was the scope of 10.0.0, that clients on that network couldn't get an IP address or a renewal of an IP address via DHCP. So let's go ahead and click on scope 10.0.0 and take a closer look at it. If we right-click on that scope, and then from the drop-down select Display Statistics, it indicates here that there's 0 addresses, 0 in use, and 0 available. Well, that is a problem. Let's go ahead and close that, and let's click on the address pool just to see what the range is. And as my neighbor used to tell me all the time, Keith, there's your problem right there. And here's our problem right here. We have it a range from 125 to 150 on the 10.0.0 network. We also have an exclusion range for 125 through 150, meaning there aren't any IP addresses to hand out. This would be very similar to a situation where we had a pool size, a range that was too small, and all the IP addresses were used, and we didn't have any additional IP addresses to hand out. So we could go to our customer and say, okay, so you have an exclusion range from .125 to 150. Do you need that range to be excluded? And if they say yes, the other option then would be to extend the range. So we could make the range from like .2 all the way through .150, or .2 through .254, assuming we had a 24-bit mask on this 10.0.0 network. And that would free up some addresses. So to modify the range, we could select the scope, right-click on it, select Properties from the drop-down, and we just change the range right here. We could change the starting range and the ending range. And then once we do that, we'll have additional IP addresses because we made the range bigger that the DHCP server can then hand out. Or we could use a PowerShell command to extend that range. So if we click on Cancel here, And if you want to open up PowerShell on this Windows 10 client, I've taken the liberty of doing a Control-Shift-R as we have many times previously, and I've opened up a tab over to DC-Nug. And the PowerShell command that we could use to change the range for a scope is set-DHCP server v4 scope, and then we'll use the -scope ID, identify the scope we're going to change, and then specifying the new start range and the new end range. So if we wanted the range to be from .2 to .150, all we need to do is select that row, so it's highlighted, hit F8 to execute it, and it's done. And now if we go back to the GUI, let's go back to DHCP Manager and do a refresh. So I'm going to do a refresh at the server level. I'm going to click on the server and then right click and select refresh from the drop down. And then we'll expand IPv4 again and go to the 10.0.0 network. And you'll notice next to the scope, we no longer have the little exclamation mark. Now we still have one up at the IPv4 level, but not for that specific scope. And to take a closer look, we could click on address pool just to verify the range. Now it's from .2 to .150. That's great. And if we select the scope and right click it, and from the drop down select display statistics, this looks a lot better, showing us that we have a total of 123 addresses. And because we have 0 in use, that means we still have 123 available. Clients should now be able to get an IP address because there's available addresses to give. All right, fantastic. That's 1 down, 3 to go. The other item on our list was that scope 10330 has an unequal split between DC-Nug and server 2. So if we look at that scope on DC-Nug, the 10.3.3 scope, based on our name we gave it, we are doing load sharing. And if we go down to server 2, the scope is there as well, because server 2 is the other half of the pair for DHCP failover in a load sharing configuration. So let's take a closer look at the DHCP failover relationship that they have regarding scope 10.3.3. Now to do that, I'm going to click on IPv4 up under DC-Nug, right click, and from the drop down go to Properties. And here on the IPv4 Properties we have a tab for failover, so we'll select that. And then the first one here that's highlighted based on the mode is load balancing, and if we do the second failover option, that's the one for hot standby. So we're going to focus our attention on the load sharing relationship because that's the failover method that gives us the option of splitting, like a 40-60 split or a 50-50 split between the two servers. So with that highlighted, we'll click on Edit to look at the details. And if we look at the ratio, which is right down here, this is saying the local server, so this is DC-Nug, who has a relationship with server 2. The local server is at 90%, which would explain the reason the customer is having DC-Nug get a lion's share of the leases and doing a lion's share of the work, while server 2 is doing only a fraction of that. So if they wanted a 50-50 split for this load balancing option, all we need to do is simply bump up the numbers. So I'm just going to highlight the bottom one and type in 50, and that will make the other one 50. Doing the math there for us, making it easy, and we'll click on OK. And we'll click on OK again. All right, my friend, that is 2 down, 2 to go. Let's take a look at that list again. So we've knocked out that, which is based on the load sharing failover not being configured 50-50. And for the 10.0.0 network, we increased the range for that scope so we'd have more IP addresses on that subnet to hand out. Next, let's take a look at the 10.0.1 scope and see what's going on with that one. So one good practice here is to refresh the screen to make sure we're looking at the latest and greatest information. So I'm going to click on DC-Nug and click on the refresh icon. And then let's expand IPv4 and look at that. We still have this icon here representing there's a problem or an issue. So I don't see any other alerts here. And also I don't see the 10.0.1 scope. So if we expand our super scope, there's the 10.0.1 scope right there hiding. We tucked it in when we created super scopes in an earlier nugget. And it looks like, based on the little red down arrow for that scope, that it's not active. See, if it was active and just out of IP addresses, we'd have a little exclamation mark that's blue. But because we have the little down arrow representing that it's not active, I'm thinking the thing we need to do is right click on it, and from the drop down, go ahead and specify we want to activate it. And then we'll click on refresh, and check that out. The icon next to IPv4 now went to green. And if we select the 10.0.1 scope and then right click on it and select display statistics, it indicates that it's got IP addresses ready to go, which is fantastic. So we'll click on close. Also, if we just wanted to find out from an IPv4 perspective overall for a server, how many IP addresses we have available, we could select IPv4, right click, and then from here do a display statistics. And that's going to give us statistics for all of the scopes, including statistics on the number of discovers and requests and acknowledgments and so forth that have been happening on the server. So we've got 7 scopes. One of them has a delay. That's the millisecond delay set for it. There's over 1,200 addresses. 4 of them are in use, which leaves a whole boatload of addresses still available. Fantastic. So we'll click on close there. And we had one other item. Let's check it out. And then the last item on this list is server 2-nug seems slow to respond on all scopes that it supports. And regarding slowness, which is a relative term, there could be lots of things that are causing that. Maybe we're running out of juice, we're running out of memory or CPU on this device. Or maybe we have the millisecond delay set up for like 500 milliseconds on each of its scopes, which is causing it to be a little lethargic in responding to DHCP discover messages. And there's one other item that we could also check on that could be slowing down the server just a little bit, and that is conflict detection. And here's how conflict detection works with a DHCP server. Before it hands out an IP address, it tries to ping that IP address. And we might ask the server, well, if you haven't assigned an address out, why in the world would you try to ping it before you ever hand it out to a client who's asking for an address? And the DHCP server could say back to us, well, if I ping it and I get a response back, that means that somebody's got that IP address already in use on the network, and I don't want to hand out the same IP address to another client, a different client, because then we're going to have a duplicate address situation on that network. And that could happen a couple of different ways. One is you could have somebody who's configured a static device on the network not knowing it's in the range of the DHCP server. Or maybe the DHCP server database regarding what IP addresses it's already handed out. Maybe it's corrupt. Maybe there's problems with those records. So regarding conflict detection, we can go in and we can specify that we want to do it or not do it. And it really doesn't make sense to do like 5 pings. Right? 5 attempts to verify an IP address before you hand one out. Maybe like 1 or 2 at the most. So on a busy server, if it's trying multiple times to ping a device that doesn't even exist before it ever makes the decision to hand out an IP address, that could certainly slow it down. So let's go back to our client. So here in our Windows 10 client, let's go ahead and collapse DC-nug. We'll focus on server 2 for a moment here. So with server 2 selected, we'll right click and do a refresh to make sure we're looking at the latest and greatest information. And we could select IPv4, right click, and then from here do a display statistics, and that would confirm several things for us. So it's got 3 scopes, only has 1 scope configured with a delay. So if it's slow on all scopes, not just that one, we can maybe rule out the fact that it's the delay value because it's not even configured on 2 of the scopes. And then we have total addresses in use 2 and available 630. Now in your lab environment, depending on whether you powered on client 2 or not, or how long it's been since client 2 has been on the network, your numbers may vary a little bit, but you'll have at least 1 for client nug because we're currently logged on to client nug and we're using that computer. So let's go ahead and close the statistics. And here under server 2, let's go ahead and select IPv4, right click on IPv4 and go to the properties of IPv4 because I want to take a look at the conflict detection settings and see what they currently are. And they keep those on the Advanced tab here under IPv4 properties. So conflict detection attempts, currently someone has set that to the maximum value here in the GUI, and that is 5, which is a long time. That would be a good reason why the server is taking so long to hand out an IP address. It's doing a ton of conflict detection first for every single lease it's about to hand out. So if we set that down to something more reasonable, for example, I think 1 is reasonable. And if you're paranoid, maybe 2. And then we can click on OK or Apply, and that change will be set. Another thing I'd like to point out to you right here on this Advanced tab regarding IPv4 properties is this option right here, Change Server Connection Bindings. By default, the server is enabled and listening on all of its IPv4 interfaces it has. So if we clicked on Bindings here, if we didn't want this server to be listening on a specific network, for example, maybe the server is multi-homed, has 5 or 6 interfaces, and on subnet 20, we don't want that DHCP server function happening from this server on that interface. All we need to do is remove the check mark or check marks next to the interface or interfaces where we don't want this DHCP server to listen for and support DHCP clients. So I'm going to leave it enabled on both of my interfaces here on server 2. Click OK. Click OK again for the conflict detection attempts being set to 1. And let's go look at our task list and make sure we got everything. Now that we've solved these items for the customer, I also want to point out that we could have a situation where the DHCP database and the registry on the DHCP server are not in sync. Perhaps we have some records that never got written to the database, but are active leases, or we have some corruption. There's a couple of commands I want you to be aware of that we could use to help reconcile that. So back here on the DHCP manager, running from our client machine, if we want to do a reconciliation just to verify that the registry and the database are in sync and that there's not a problem, we could right-click on IPv4 and from the drop-down choose the option called Reconcile All Scopes. Or if we want to do it for a specific scope, you could just grab that scope, right-click on it, and then reconcile just that scope, either way. So if we go back to IPv4 and we do all scopes, it gives us a window that says this procedure compares scope information in the database with the registry. And if we click on verify, it'll do it. And we have a message saying the database is consistent. So we'll click on OK, and we'll go ahead and click on cancel there. And we also have the ability to do the similar functionality through PowerShell. So here on my Windows 10 client, I have a remote tab opened up to DC-nug. And if we wanted to reconcile the records for the scope 192.168.1.0, which is on DC-nug, with that row highlighted, we'd hit F8. We have a pop-up message saying database inconsistencies on server DC-nug for IP address records in the specified scopes will be reconciled. So we'll say yes to that. And we also have a repair-specific command of repair-DHCP server v4 IP record. So I wanted you to be aware of these two options in PowerShell regarding reconciling the registry and the database to make sure there's not an inconsistency between those two regarding DHCP. And now, my friend, it is your turn. I invite you to do the hands-on lab, walk through the troubleshooting exercise like we did together, and that will reinforce the learning that's happened in this nugget. It will also improve your skills in becoming aware of and troubleshooting DHCP configuration-related items. And when you're done, I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.